We start with question 7D. Question 7 part D. Evaluate the indicated limits if they exist. The function is h of z is equal to the lim of absolute value of z minus 8. Then find the lim to 8 from left, lim to 8 from right, then the lim to 8. So let's work it out. So limits. We are doing limits. This is our first question. Example 1. Find lim as z goes to 8 from left, of f of x, to lim as z goes to 8 from right, f of x, 3 lim as z goes to 8 of f of x. Given f of x is equal to lim of z minus 8. Now you understand that everything that you know about limits in terms of substitution or simplifying so that you can substitute does not work for this function because of lim. If we try to substitute, this is lim, we try to substitute 8 and get 8 minus 8, this is going to be lim 0. Lim 0 is undefined. So because of this, the only way out is to sketch the function. So solution, we'll have to sketch the function. So sketch f of x is equal to lim absolute value of z minus 8. To sketch a lim or a log function, the first thing you do is you get the inside of log z minus 8 absolute and equate it to 0, implying that z minus 8 is equal to 0, and so z is equal to 8. This is z. Called the vertical asymptote. So when sketching, so far we have found the vertical asymptote, which is 8. I'll put it here. Okay, from there, we find the x-intercept. To find the x-intercept, we equate the whole function to 0. Okay, this was step 1. This was step 1 in the sketch. This one, step 1. Step 2, we find x-intercepts. On this question, we are also learning how to graph the log functions. 1, 2, how to solve the log equations. Because now for us to get the x-intercept, we equate f of x to 0 and solve. That is lim z minus 8 is equal to 0. And what is ln? Ln is log base e, and then z minus 8 is equal to 0. Every time you find yourself solving log equations, you convert them from logs to exponential. How do we convert? We have z minus 8 absolute is equal to e or 0. So we get z minus 8 absolute is equal to 1. How do we remove the absolute? For the sake of equation, we just do plus or minus z minus 8 is equal to 1. So we have plus z minus 8 is 1, giving us z is equal to 9. When we pick the minus, minus z minus 8 is equal to 1, giving us minus z plus 8 is equal to 1. So we get minus z is equal to minus 7. Then divide by negative. So z turns out to be positive 7. So we have two intercepts, positive 7 and positive 9. And since our line is positive outside, as you can see, it's positive outside here. And that means the function goes up. The function goes up. Because it has touched the y-intercept, the y-axis, we must find the y-intercept. So how do we find the y-intercept? We do f of 0. Where there is x, we take 0. So we have ln 0 minus 8, which is ln minus 8. The reason why this absolute is to get rid of the negative. So we get ln 8. We have sketched. And that's how you sketch if the absolute is inside ln. There's a difference. If the absolute was outside, if it was ln z minus 8, the absolute outside, the sketch would have come out different. Would have only had one sketch this side on the right, but then it would have come here and go up like that. And not the other one. Okay. After that, we can now answer the question. What is the limit? Part 1. The limit as z goes to 8 from left of f of x of ln z minus 8 is equal to, you're observing as x is getting closer to positive 8. What is happening to the function, to the values of y? The values of y in this curve are going to negative infinity. So the answer is negative infinity here. Part 2 as well, you check what is happening to the limit into the function as z goes to 8 from right of ln z minus 8. So again, you realize that as x is going closer to this 8, the function is coming down, down, down to negative infinity. So altogether, if the side limits are equal, then this means that we now have the limit as z goes to 8 of ln z minus 8 to be equal to negative infinity. Like that. if you are asked if the function is continuous at negative, I mean at positive 8, you say the function is not continuous because f of negative 8, I mean f of positive 8 is not defined. As you can see, at 8, we have an asymptote. Our next question will come from question 10 and question 15. And we are looking at E. We attempted A, so we need to make one credit there. On question 15. On 15A, the function of f of x is equal to 10 minus 3x squared plus 2x power 3. Okay. Recording what we did, we managed to, after we differentiated the function, we got negative 6x plus 6x squared. And then we found the critical points to be 0,10 and also 1,9. Then we got the second derivative to be negative 6 plus 12x. And then we equated it to 0. And we had negative 6 plus 4x is 0. So x came out to be positive half. Then on the question of concavity, we tested half was in between. We picked a number less than half, 0. A number bigger than half, 1. And then we are testing using f prime prime of x. When we substituted for 0, we got negative and then positive. So we say f is concave down where f prime prime is negative, that is from negative infinity up to positive half. And f is concave up on from positive half to positive infinity. The question of interest is part 5, where we are finding the point of inflection. Remember, I had said that there is no point of inflection here. I think I didn't consider the other parameter that is used to determine the point of inflection. My eyes were just on the critical points. But then, if you go as far as the second derivative to find the point of inflection, you look at this table here, where the function changes the concavity. If it was concave down, then it becomes concave up. At that value of x, the function has an inflection point. So we have an inflection point at half, comma, f of half. Okay, at half, it's changing from concave down to concave up. So it means this is an inflection point. So now let's find f of half. We substitute the original function 10 minus 3 half squared plus 2 half power 3, which is 10 minus 3 over 4 plus 2 over 8, which you can write as 10 over 1 minus 3 over 4 plus 1 over 4. 4 common denominator, then we get 40 minus 3 plus 1, which is 38 over 4, giving us 19 over 2. So we're getting the point as half, 19/2. This is the point of inflection. This one. So how do you find the point of inflection? Get the second derivative, equate it to 0. The numbers you find, that's a critical number. Use it on the testing table using the second derivative. Where it is negative, the function is concave down. Where it's positive, the function is concave up. Where the function changes the concavity from being concave down, concave up, that point is what we call the point of inflection. And so now, if we are to sketch this again, hello.
Can you just like write the command notes down there about the inflation?
Okay, I'll do. So we have 0,10, and then we'll have half, 9/2, I mean 19/2 here, and then we have 1,9 here. So when we sketch, this was relative maximum, and then this was relative minimum, and then there is concavity here. So when we say concavity, the function does a bit of some resting here, and then it comes aside. So that is the point of concavity. Okay. Not the point of inflection is the point where the function changes from concave down to concave up, or from concave up to concave down. Remember, we wrote a note on how you check concavity. So you're putting those two together. Like that. So here we just came to make the correction statement on the point of inflection. Let's go to E now. 15E. The function G is equal to E power 4x minus E power 6x. So for us to sketch, we must first find the critical points, determine the intervals of increasing and decreasing, classify the critical points as relative maximum, relative minimum, or neither, determine the intervals on which the function is concave up and concave down, the point of inflection, and then we'll be able to come up with a sketch. So we start part 1, critical points. So we differentiate the function. Now this is exponential. To differentiate exponential, you differentiate the power 4x. The derivative is 4. Then multiplied by e 4x. Minus, again, you differentiate the power 6 and then e 6x. The next thing is we equate the first derivative to 0. That means we have 4e 4x minus 6e 6x is equal to 0. So if we take this the other side, we'll get minus 6e 6x is equal to minus 4e 4x. And then we divide this side by negative 6e to the power 4x, and this side also by negative 6e to the power 4x. Okay, so that this e4x and this e4x can cancel. This negative 6 and this negative 6 can cancel. So we are now remaining with e6x over e4x to be equal to negative, negative, and then we remain with 4 over 6. This, because of the same base e, we'll subtract the powers, 6x minus 4x, giving us 2 over 3. Because 2 can go into 4 twice and into 6 3 times. And this is just e to the power 2x is equal to 2 over 3. So from here, we are solving the exponential equation because I've equated to 0. Then how do we find the values of x? You apply ln both sides. We apply ln both sides. So that the 2x can come down, and then ln e is 1. And so we get ln 2 over 3. And divide by 2. Divide by 2. So we get x is equal to half multiplied by ln 2 over 3, which you can also write as ln 2 over 3 to the power half. So this is the x value that we have as a critical value, meaning that we only have one critical point. So we only have one critical point. How do we find the critical point? We get this value, substitute it in g. So we have g of ln 2 over 3 or half, which is equal to e 4, where there is x, we are putting ln 2 over 3 or half. And then minus e 6 ln 2 over 3 or half. So those coefficients of ln can be taken to be the powers now. So we have ln and then 2 over 3 power half multiplied by 4 minus E ln 2/3 multiplied by 6. So that E ln, once they meet, they disappear and we remain with 2/3 to the power half times 4, that is just 2, minus 2/3 to the power 3. And what we get, this is giving us 4/9 minus 8/27. 27 common denominator, and then 9 into 27, 3. 3 by 4, 12, minus 27 itself, then multiplied by 8, giving us a value 4/27. So the critical point that we have, the critical point is ln 2/3 to the power half, comma 4/27. This is a critical point that we have.
Sir,
Hello.
there on the is, how have they disappeared? I didn't get.
Every time you have e to the power ln, whatever is here, it becomes the only thing you remain with. The same way we say ln e is 1. Now, if it's the power thing, it then become 1 to the power something. That something becomes down, and then that thing becomes 1. So it's like we are dropping the inside thing.
All right.
Then, well, we need to maybe classify first. So let's classify. So we get the second derivative. So we're coming back to differentiate this first derivative. So 4 times 4 now, we get 16 e 4x, and then minus 36 e 6x. So we're multiplying 6 times 6 to make 36. Like that. How is this helping us? We want to substitute the value of x that we have. So we are doing g prime prime of ln 2/3 half, which is equal to 16 e 4 ln 2/3 power half minus 36 e 6 ln 2/3 power half. Oh, and we've already seen that when we work out this, it's just giving us 2/3 to the power 2. So we're multiplying 16 by 2/3 power 2, and then minus 36 by 2/3 power 3. So now, what are we getting? 16 times 4, that is 64/8, minus 36 by 8. What is that? 36 by 8. That is 288/27. So if we work out this 27, so I wanted to say 27 common denominator. Here 8 is not going there. But the concept is we are trying to see which one is bigger than the other here. So of course 288/27 is bigger than 64/this. So this number is less than 0. Telling us that this is actually the relative maximum. To get 16, we differentiated the first derivative. How do you differentiate e? You differentiate its power, then you multiply by the coefficient which was 4 there, so we have 16. You differentiate 6x, you get 6, then you multiply 6 by 6, you have 36. And that's why it turns out to be like that. Hello.
Can you repeat what you said on the second derivative? How did those powers on 16 and 36 disappear?
So we're saying this here, this is exactly what we have here. It's exactly what we have here. And we worked out this, we got this part. So now on this whole part, I'm putting 2 over 3 to the power 2 because I've already worked out that thing. The same thing is happening to this one. This is what we have here, which we worked out to get. We worked it out to get this one. That's why we just dropped it here. But there was no 36, that's why I'm multiplying it by 36. And there was no 16, that's why I'm multiplying it by 16. The target here was to name the point, and we have named the point. And of course, if we name it relative maximum, it means we know why the function is increasing and decreasing. Because before it becomes maximum, the function was increasing until it reached that value of x. Once it reaches, for it to become maximum, it must start decreasing. So we are saying increasing on negative infinity up to ln 2 over 3 power half. And decreasing on ln 2 over 3 power half, comma, positive infinity. This is where g of x is increasing and decreasing. So what's remaining is to come and check concavity, inflection, and the sketch. I'll give you, this is 2027. I'll give you 15 minutes to try and make sense out of what we have done so far. At 20:45, we're joining again. So we can sketch this and then touch some other parts. Anywhere we'll touch into sheet 9 and 10. If there'll be nothing, we'll go to sheet 5, 6, 7, 8. So we're joining at exactly 20:45. We'll try to go through this. Okay, question 15b.